This video discusses multiple choice questions 56 through 75 on the 2013 released International AP Chemistry exam. So digging in with number 56, I pray that we automatically recognize this is a weak acid strong base titration. They are asking for us to identify the acid. Well, we know at the equivalence point, 25 mils about. So at 12.5, the pH is the pKa at the halfway point to the equivalence. So I estimated about 3.8, and that is the correct answer, B. 57 is asking us to recall the periodic trend of size. So they are giving us 3 elements within the same period. We know as we move left to right that atomic size decreases, thereby having this order of increasing size. Magnesium is furthest to the left, so it would be last. Chlorine furthest to the right, so it would be first. Choice A. 59, we are given the overall reaction and then our reduction half reactions. So if we really focus on, all right, what do we need to do with these half reductions to yield this overall reaction? Well, the silver ion is a reactant, but we have 3 moles of it. So what we need to do with that half reaction is multiply it by 3. So our coefficients become 3. However, remember the standard reduction potential does not change when we change the coefficients. So that remains 0.80 volts. But the first reduction we have to flip. We don't have to change the coefficients at all, but of course our E value changes sign. Remember, that's the only thing that changes about standard reduction potentials. Then to get the overall reaction, we would add these. We get 2.46 volts, which is choice D. Number 60, that is setting up kind of a straightforward ice table. If we just recognize that we are given 4 moles of each gas in 1 liter vessel. So that would be 4 molar of each to start, none of that. But we're told we have 6 molar of Z once we've reached equilibria, which would be our 2X. So X is 3, applying X and then plugging into the K expression, we get 36, which is E. Okay, then 61, application of half-lives. So after 1 minute, if the half-life is 15 seconds, we've gone through 1, 2, 3, 4 half-lives. So as a fraction, at the end of 4 half-lives, we would have 1/16 left, and that is choice E, the correct answer. 62, we just have to remember graphing of what confirms second order. So to agree with the integrated rate law for a second order reactant, it's Y equals mx plus b, linear with a positive slope of inverse of concentration versus time. That is choice D here. Be careful, because of course we're not after the negative. They're not even giving us, we know that the graphing, if it's second order for concentration versus time, would be curved for second and first order. For first order, it's natural log of concentration versus time. That would be a negative slope for us. Okay, so on to 63. It's a limiting reactant. Now, your work, I'm sure, would take much less time than mine, because I wrote out all of my, full units. So the math is very cooperative. What I did is just reduced where I could. So 2 and 20, I made this 10. I waited to divide till 1,000 until I got my numerator, and then, just move my decimal place. But that made it much easier for me to be able to see the cooperative math. But this ends up being our limiting reactant, and we get just 0.010 moles of carbon dioxide, which is choice D. It's asking in 65 for which would impact error the least. So what we have to understand that we're doing here is combining, going into it, 0.5 molar, 0.5 molar. So if we're trying to get the heat of reaction, we're doing calorimetry. And so we're going to be measuring mass, determining specific heat, which when we mix solutions of these concentrations, I bet we're saying it's probably, 4 gram or joule per gram degree Celsius, right along with water. But we need the change in temperature. So really we're looking at what will impact these the least. I would definitely say A, because if your thermometer is not calibrated, then because we're looking for the change in temperature, then the initial and the final will also be, quote unquote, 0.5 degrees Celsius too high. So the change will be okay. Where all the others impact the mass or the change in temperature. So definitely A would have the least significant impact on the finding of the heat. 66 is seeing if we understand what is going on during a phase change. And so if you remember warming curves, it's saying that we have some of our solid that is in equilibria with the liquid, and we are investing heat, but temperature is not changing until we've completed our melting. So on our warming curve, we're transitioning from left to right here. So where's the heat going to? It's going to make the kinetic energy and particle attraction equal. So it's going to impact particle attraction. It is not breaking bonds. Forming bonds would be a chemical reaction. So B is definitely the best choice. Absolutely hands down the best choice. Okay, then we go with 67. And 67 is really looking for the definition of what a catalyst is. Lowers the activation energy. In 68, you are employing the dilution equation. And so, a little bit of long division, but what we find is A is our choice, 0.025 molar. In 69, B, because it would be copper 2 oxide, the charge of copper here is positive 2, not positive 1. Remember that a single bond is a sigma. The sharing of electrons are between the plane of the nuclei. A double bond is 1 sigma in the plane of the nuclei, but then the sharing of electrons has to go outside that plane. It would be the overlapping of unhybridized p orbitals, but we just have to know it's outside the plane. So it'll be 1 pi. And then a triple bond, we first share in the plane, and then outside, and another place outside. In either, the y axes and the z axes, if the x is taken, and so on. So just a breakdown of that. And so, don't you know that here we're seeing, remember I've given you in the first video kind of those go-to structures that are just good for us to know. Of course, that would be carbon dioxide and nitrogen. Well, this is out because this is 1 sigma and 2 pi. And this would be, each of these would be a sigma and 1 pi. So 2 sigma and 2 pi. So that's out. And then going through. So it ends up being A because of this triple bond. So each of the single bonds is 1 sigma, but one of the triple bonds is also a sigma. And then the other 2 pairs are 2 pi. So that's what fulfills the question. 73, the only one, and again, look at 73. It has carbon dioxide, it has water, it has methane. So those are kind of the go-to, 3 of them that we want to know. You definitely know that those won't resonate, but ozone. So I just chose to have this, the center and the one to the right double bonded, but someone else might have chosen it to the left, so we know that that will alternate. And so this shows resonance. So B is 73. 74 is just a calculation of molarity. And I, just to show you the question real quick, and I set it up, and again, like the math, I saw that this would reduce to 1/3, and then 1 divided by 0.25 is 4, so 4/3, it'd be 1.33. But we need 4 sig figs, and so that's what makes C correct over D. And then 75, remember strong electrolytes have many free-moving ions. This is covalent molecular. These will not dissociate or ionize. Non-electrolytes. Acetic acid is a weak acid. It'll partially ionize. Not a strong acid or not a strong electrolyte. A weak electrolyte. Ammonia's weak base. So it will just create a small number of ions. But sodium nitrate, being ionic, we know that sodium nitrate will completely dissociate. All sodium, all nitrate compound soluble. So you will get complete creation of cations and anions. So for 75, choice C is it.